So, as I mentioned before in the beginning of class, I'm going to do the part of the week 2 lecture, and then I'll go over the answers to the homework that I gave you last week, and then we're going to try to do a little bit of week 4's lecture as well. So, I didn't get a chance to really talk about this but I think it's really important to discuss why we're learning about object-oriented programming. Why does this class even exist? Like, what's the point? Why aren't we learning just more like game development stuff? Well, turns out once you start getting into more and more programming, new problems kind of start to appear that you didn't really encounter before. Problems such as complexity of code. Things like your code it's buggy, it doesn't seem to work right because it's either too big or it's too complicated or too many people are working on it and there's not a good way to organize things. Like, having a method to organize and manage your code becomes exponentially more important the more complex your game or program is. When you take a game like Overwatch, or any game really that's like a professional quality game, you really have to follow a certain set of guidelines. Okay, these are basically recommendations for you, like things that you should be doing. They aren't required to use C++. As you guys know, like, you're able to make Pong and you're able to write programs without knowing about any of this stuff. However, it's more like, here are best practices, and these are so important to think about that they're actually built into the language as features for you to use. And these get important because when you're making a game that's as big as Overwatch and you have so many people working on it, you don't really have time to get caught up in fixing bugs as a result of complexity. Complexity of your code is always a constant struggle that you're fighting against. As you add more stuff to your game, you're adding more code, and you also are at the risk of adding a lot of complexity. And complexity rears its head in a lot of different ways. Some of them are like the game becomes a little bit more unstable. It's like a slow thing. Like, maybe the game's fine. Maybe, 1 million people play Overwatch today or this week, and then maybe 100 of them crashed while they're playing the game. You added a new feature. Let's say you added something for, let's say you added a new hero, and that new hero has some interesting interaction because we had to add new code to support that new hero. Now all of a sudden, 1,000 people are crashing during the week. And it's hard to really quantify that. Like, I'm just kind of making these numbers up. But the point is that as we added that hero, we added some code, we added some features, we added more interactions with that hero against the rest of the game that already exists. And we want to minimize the amount of kind of disturbance or turbulence we cause as a result of adding that hero. We want to make that hero something that can stand alone and doesn't really cause instability with the rest of the game. Which, if more players are starting to crash, okay, maybe it's fine for one patch, but what about the next hero we add? What about the next 10 heroes we add? And all the different game modes we might add, or the different features we might add? Who knows how much more unstable the game might get? Managing this complexity and keeping our game going along and developing at a good pace is supremely important. It's kind of like oil for an engine, right? Like, you want something to make sure that the lifetime, as long as you're maintaining the engine, as long as you're doing a good job of changing oil out at the right intervals and performing regular maintenance, your engine will probably run and last for a while. If you neglect that maintenance and you skip a few oil changes and you don't do your regular standard recommended maintenance, your engine probably, the lifetime of it won't last as long because it tends to get a little bit more worn down a little bit quicker. So object-oriented programming is the same kind of concept. It's kind of like a way to write your code so that it has a longer shelf life. It has a way to last longer without having to worry about the code breaking down on you. This is kind of a hard thing to understand if you haven't actually experienced it, but from personal experience, like, for instance, game jams are a very common area where this can happen a lot, where you do what's called hacking, and not like hacking like movie hacking, but more just, okay, we have 2 days to get this thing done, all right? I don't really care how it's done, we just need to get it in as fast as possible and screw any bugs that might happen, or I just know a very brute force way to do this, which means I know one way to do it and I'm going to do it that way and no other way. And it might take like an hour for me to write the code, but it'll work. And when you get into something like a game jam, personally I've experienced that after you're done with that game jam, your code is like a mess. It's like in a state where if you went back to it after like a year and you're like, oh, I want to make more improvements to that game, you'd be completely lost. You wouldn't have any idea where to start, and that game would be kind of buggy and wouldn't really work right. However, for a game jam, that might be fine, but for like an actual product that you're working on, it really is important that you follow some of these concepts I'm about to talk about. That's why like getting into OOP, object-oriented programming, it's more of like a, hey, this is an approach that you take. Not necessarily, we're going to talk about some of the syntax that you use to apply this to your games, but really programming is about thinking about your game in a different way. It's about thinking about how to organize your code, because there's an infinite number of ways like you can make a game. Like we could all make Asteroids here or Pong, and we could all do it differently, and it can all look the same. However, we all took different roads to get to the same product. And some of the ways can impact how long it takes to make it. For instance, for instance, let's just say I clone myself and there's two of me, same skill set, and we both went out to make Pong. And one of us used Pong, created Pong using object-oriented programming, and the other guy created Pong using whatever hacky method he could. And the difference is that we might end up with the same game. It might look and play the same. The difference is that the guy that used object-oriented programming, that guy might have been able to do it much faster. So maybe I did it in like an hour. And at the end, I was able to get something that I can easily change and add more features to without breaking it. The other guy that did it as fast as he could without using object-oriented programming, it might have taken him 2 hours to do it. It still got the same result, still looked like Pong and played like Pong. However, afterwards, if he said, let's say he wants to add 4 players to Pong instead of just 2, or like he wants to add power-ups to Pong, because he didn't necessarily follow the same principles, it might be more difficult for him to add those features in. So that's the thing I kind of want you to remember is the end result might look the same. However, like it's kind of like what's under the hood that matters. And especially when you're working on something that's like a live game, this kind of stuff actually matters a lot. Are there any questions about that? That's kind of how I want you. This class is meant to kind of show you how you can think about making a game a little bit differently. Okay. All right. It's also where the plus comes from in C++, because that's C++ added the concept of object-oriented principles. So these object-oriented principles, there's quite a few. I want to talk about what we're going to be solving. The book calls these the most important principles of object-oriented programming. These, again, are, you can think of these as like a state of mind, almost. I don't want to sound all like Bruce Lee style, like, flow like water kind of thing. No, it's more like, how do you approach organizing your code? Where do you put your code? In what places do you put your code, and how do you interact with your code? And these principles here are really important to object-oriented programming. We're going to talk about classes today. And classes are one of the most important ways to like take these concepts and integrate them together. A few things that classes actually we're going to talk about today and explain via classes are the concepts of abstraction, encapsulation, and data hiding. Eventually, we're going to talk about inheritance, and we're going to talk about reusability of code and polymorphism in a few weeks. But today, we're going to talk more about abstraction and encapsulation and data hiding. And I'm going to explain what those mean, but I just want you to know that classes are a way to use those principles of object-oriented programming. We're going to talk about how to like create a class and how to actually declare classes, class members as public or private. Okay. Okay. So we actually did a little bit of something that looks like classes before. I want to just talk about like a little bit of the syntax and the what classes look like and what they do. And then I'm going to talk a little bit about how to use that with games. So classes, it's a name that's given to something that represents a data structure. A data structure is a way to combine multiple disparate pieces of data into a single unit. So you have something like here. I have an example here, which is something called a product, but I'm going to go into a little bit more examples, game-related examples. Classes are an expanded concept of data structures. When they say data structures, they literally mean the word struct. Struct here is something that we used before in the last class. I want to say like around week 4, week 5. We talked about structures briefly. This was related to when we're dealing with Pokemon. And so when we had Pokemon and the Pokedex example. Data structures, the important thing to remember about classes is that there are really 2 pieces to every class. And remember that a class is a vehicle for applying object-oriented programming principles. And there's 2 pieces to a class. You can either store data in a class, which means that literally you're storing numbers or strings or other classes. You're literally storing information. You're literally storing variables inside a class. Or a class can also have functionality associated with it. You can do things to a class. A class can have functions that you can call on it to have it operate on its own members. Both functions and variables that live inside of a class are called members. Members mean that it belongs to that class. So here, this structure for a product has 2 members. They have 2 data members, meaning that they have 2 variables. A struct for a product has an integer that represents its weight, while a double represents its price, which means that it's a floating point number representing the price. So once you have a structure, for instance, you can declare variables using that structure. Here's some kind of example syntax for declaring an apple, banana, and melon product. When you declare a structure, you're effectively making a new variable type. You know, we've been using like integers and doubles and bools up to this point, and those are built-in types. It means that they come with C++. But you can make your own variable types by declaring a structure like this. But why? I'm just talking about syntax here. I haven't really talked about when you should use them or how you should use them. What's the point of having a structure like this? Like, how does this apply to making a game? Like, what is actually the reason why I would do this over just declaring the weight and the price separately? Some of these things require you to think about organizing your code a little differently. Let's take a brief detour here. And I want to show you guys a little bit about how you can organize your code. I have to restart Visual Studio. Let's see, what's a good recent game that came out recently that we can talk about? Outlast. How about a more like RPG-ish kind of game? What's that? Zelda Breath of the Wild. Okay. It's like what everyone's playing. We can do that.
It's a good game.
So,
Escape from Tarkov.
you know, Zelda is a pretty good example because it's kind of a pretty complex game. right? Like it has a lot of pieces to it. And you ever think about how a team like that like copes with something that's so complex of a game? Like how do they actually take a game that has so many different interactions and has such a unique take on the open world genre, and how do they organize it in code? So we're going to talk about abstraction here. Abstraction being one of the key tenets of object-oriented programming. You actually do this a lot, like in your brain, which is to take a complex concept and create an abstraction for it. And an abstraction is kind of a way to simplify a concept by, instead of focusing on the details, you focus on the abstraction instead. For instance, a perfect example of this is your car, if you drive one, which is how do you make the car accelerate? You push the gas pedal down, right? And in your head, that is an abstraction of all the different mechanics that go on to actually, inside your internal combustion engine or electric vehicle, that actually cause your wheels to move, that actually cause your car to move forward. You've abstracted that concept away, and you're literally like, I want to go, so I push this pedal. I want to stop, so I push that pedal. And that abstraction is everywhere, right? Like you don't necessarily think about every single detail when you're dealing with objects. Like a key, for instance, is an abstraction of how to unlock something. You don't necessarily care about like how the key is made or what the key is made of or the interactions with the key and the lock. You just know you push the key and you turn it and it unlocks the door. Those abstractions are really important because what if every time that you had to open a door with a key, you literally had to set the pins yourself every time? You literally had to know the internal mechanics of how the lock worked. Or every time you press the accelerator on a car, you had to manually do something where you had to understand like how much to engage the throttle, or like how much to adjust the fuel to air ratio in your engine. All those things are hidden from you. They're abstracted away from you. Someone at a company has developed a way to just have you think about it as pushing a pedal or not.
Yeah, before it used to be stick shift.
Well, yeah, I mean, it's still stick shift now. I mean, stick shift is a good example where an automatic transmission is an abstraction of the transmission gears that occur in an engine. And some people like to not have that abstraction. But as far as an abstraction for programming is concerned, you want to think about it the same way. What if you take a game like Zelda and you want to have something where you're writing your code. Let's say you're a programmer on the development team, and you're told to make sure that when Link jumps off of a cliff that's big enough, he dies when he hits the bottom. Okay, falling damage, right? When you have abstraction done well, that programmer already has all the facility he needs to have Link die when he hits the bottom. He has a way to apply damage to Link already. Now, applying damage to Link is actually an abstraction concept. Like when you actually apply damage to Link, what do you think actually happens? Well, Link has some health. He has animations that he plays. He has effects that play when he takes damage. UI needs to update when he takes damage. He loses hearts. And if he takes enough damage, he needs to die, right? But a lot of things cause Link to take damage, right? Like monsters cause him to take damage, or cliffs cause him to take damage, or getting hit by lightning causes him to take damage, right? All those things do the same behavior of causing him to take damage. So it would make sense that there's an abstraction for the concept of applying damage to Link. So that if all of us were on the development team and we're all tasked with causing Link some amount of damage, we're not all implementing damage our own way. We're not all going through the process of updating the HUD, playing the effects and the animation. We're literally just doing one thing, which is there's an abstraction for something like take damage. And in this case, the abstraction here is a function. But this is an example of how we would take all that complexity and hide it under another layer, which is a function, right? So we're going to take that concept and apply it as well to a class. A class is just another way to abstract out a concept, which is usually combined of two things, either data members or function members. So let's make an object to represent Link, okay? And I'm going to do this in Notepad. I want to do this exercise because I want to talk a little bit about what makes up link. And I want to approach it from the concept of what are data members for link and what are function members for link. And literally, I want you to think about this as if this is what are variables that describe link, and then what are things link can do. Okay, this is the way I want you to think about it. And this concept of what represents this object, the state of this object, which are data members, as well as the things that object can do, or things you can do to that object, are what you do when you're developing an abstraction for a concept in programming. Okay, these are the two things that you want to focus on, and these happen all the time. Like when I'm writing a program or trying to think about how to start a new thing, I'm always thinking about how to organize the concepts in that game. So let's take link, for example, in Breath of the Wild. Okay, let's try to find out things that describe link, as far as what are variables that can describe link. And we've done this exercise a little bit before, but I want to dive into it a little bit more. So I'm going to start you off here. One thing is how many hearts he has, right? And that's an integer that we're going to use to describe link, right? That's going to be a property that link has, is how many hearts he has. Can anyone think of any other properties that link would have that explain, that describe link?
Yes, stamina.
Stamina. And armor is what? Is that a value, though?
That's part of his
Defense, yes, defense of armor.
Well, you would have a base
Defense.
value.
I think that's represented as defense, right?
Yeah.
But you guys, you're right. There is something that's like what armor he's wearing.
His inventory?
You guys are missing some simple things too. Like this is a 3D game, right? Link exists somewhere in the 3D game. His position, right? What about other things regarding his position? We have a rotation as well.
Height.
I'm going to call it, this is a quaternion.
Is height also part of position?
What's that?
Height also.
Height is part of position. Position is a three-dimensional vector. So it represents his x, y, and z values.
His movement speed?
Yes, he would have two things. He would have his velocity, as well as acceleration. Gravity is applying to Link all the time, so it's making him fall. And acceleration is a 3D vector. Like if you're in front of, I don't know if they have this, but there's like wind potentially or something that pushes you.
Yeah.
That would be acceleration that's getting applied to you, right? So this can be in 3D space. It's not always down. Or if you're going to lift it up by something, that would be acceleration up. So those represent his stats. These are properties that describe Link. This is you abstracting out the things that describe Link. All of these are going to belong to one new variable type we create called Link. We're going to make a class called Link. Okay? These things all combine to kind of represent the shape of what Link is. Let's talk a little bit about things that Link can do. And this is a little bit more, this is a little different because I want you to think about things that you, imagine this is, to be specific, these are functions you can call on this Link object to have it do something with the information that it has, or you can pass that information so you can have Link do something. I'm going to start you off with a function that doesn't return anything. Let's call it take damage. This is a function called take damage, which allows you to cause damage to Link, which would mean that you'd reduce his heart amount. What are other things that Link can do that describe, you can describe as a function?
Walking.
Walking?
He sprints as well.
Walking is an interesting one because how do you abstract it out even more? Because you can either walk or jump or run. What about things that change his speed, right? You can do a move. This is actually probably a little bit better. So if we have an abstraction, I'm going to get rid of this one here. Let's just say there's a function called move. You can tell Link to move in a direction, right? You can tell Link to move in a direction, and you can tell Link to move in a direction and whether you want him to run or not. And this direction, you can tell Link to move forward. And the thing about this is that all you're doing is you're telling him to move forward. You don't necessarily know how fast you want him to move because the speed that he moves is based on his information. No one else can control how fast Link can move. What I want you to think about is you're kind of like the controller. All you're telling Link to do on the controller is push up. You're just pushing up on the controller, right? And you can do analog movement, but for the most part, you're just telling him what direction you want to move. Other things you can tell him to do. Jump. You can also ask Link for information, actually. You can ask Link, hey, how many hearts do you have left? This actually gets into the next topic I'm going to talk about, which is how do you control who has access to what? This right here is an interesting concept here. Like you're asking Link, hey, tell me how many hearts you have left. But we already created a variable called hearts. We already know how many hearts he has left.
So you're trying to get it through.
Here, let me actually put this in a practical example. So the syntax for a class is very much like a struct. And I'm going to show you guys this on the PowerPoint here. We've described the class in Notepad, and I'm going to write it up in Visual Studio in a second. However, I want to talk a little bit about the syntax for it before I get into it, and I'll talk about how you control access to those things, because it's important. There's another term I want you guys to remember, in addition to what classes are. I want you to remember the term object, okay? An object is an instantiation of a class, okay? So in terms of variables, which means like if you think of like an integer, let's say I have an integer called health. The type of that health is an integer. And the object would be the variable itself, would be the thing that stores it. So for a class, there's two words I want you to remember, classes and objects. A class is the type, while an object is actually the variable that's used to store information. It's almost like the class is the blueprint. Like let's say you have a blueprint for making a house. A class would be that blueprint. Then you make 10 houses off that blueprint. Those 10 houses are objects. Each of those houses is an object, which is an instantiation of that blueprint. Instantiation meaning it's a created object, it's a created version of that class. It's been brought to life. It's been instantiated. So that's what I want you to think about, classes and objects. What we're going to be writing here in Visual Studio, and what's described here, is effectively the blueprint of the class. We're going to show you how to actually make an object of that class, too. So the syntax for a class is identical to a syntax for a structure, which is you put the keyword class, and then you type in the name of what you want that class to be called. Then you put all of your members inside a set of curly braces, and with a semicolon at the end. This object names that happens between the last curly brace and the semicolon is an optional concept. We don't really use this much, but C uses this a lot, which is it lets you create a variable, it lets you create an object with that name as part of the class declaration. It's a shortcut. It's not necessary. We don't do it, but I want you to show it to you so that you have awareness of it if you do encounter it. So knowing this, we have these other things called access specifiers. And I'm going to skip over that for now, and I'm going to go into the class declaration. So I have my class link. Okay, this is the basics. If you have something like this will compile and run, and you have no problem. This is something that is you should not be scared to write these. You can get comfortable writing as many of these as you can, creating classes. They're not expensive. They're very simple to write. But think of in between those curly braces as kind of like the domain that represents the abstraction for the class. So in this case, everything inside those curly braces is going to describe link, either a property that link has or something that link can do. Okay. So it's going to be a combination of data members and function members. So going back to my notepad, These are all our data members, and there's our function members. So literally, I'm going to write these inside the class. You're going to be declaring variables to start building up this abstraction of what link is. For instance, we have health. That's an integer. I put that in between the curly braces. Now, our link class has health associated with it. Before I go any further, let me show you. I can now create a variable that's a type of link. Okay. Notice the syntax coloring here, like Visual Studio is trying to help you out. We created a class called link, and now I can use and create a variable of that type. I have an object called myLink. Remember the difference between an object and classes? An object is an instantiation of the class, which means that this is the object. myLink is the object, and this is the class. That's the type of my object, which is a link class. Cool. I have a variable now. So how do I access that health? I know that link has health. I want to set that thing to 3. How many hearts does link start with? 3. Okay. But you can have partial hearts, right?
Yeah.
So if I have partial hearts, this thing should probably be a float, right? Or if it's an integer, it has to represent whatever the smallest denominator for hearts is, which I don't know if you can get a quarter.
Yeah, it gets a quarter.
You can get quarter hearts.
Quarters? Yeah.
So then, yeah, you would have that value integer represent effectively hits that he has. Anyway, we have health. So how do I set that health? Well, okay. So here's what I want you to keep in mind. This class is a single blueprint. You can have as many instantiations of that blueprint as you want. For instance, I can have 2 links in here. Shadow link? I don't know. Isn't there like shadow link?
Yeah, there is shadow link.
So I can have 2 of those, right? Let's say shadow link I want to have 10 HP and I want link to have 3 HP. What happens if I do this? This is not syntax I want you to use, but I'm doing this to show you what happens. If I set link's health to 3 here, how much health does shadow link have and how much health does link have? They both have the same. So when you're declaring your blueprint, what you want to do is understand that there's a distinction between values that you set in the blueprint versus values that you set on the object. If I want link to have 3 health, I need to set his health to 3, and I need to set shadow link's health to 10. Okay? Each of these objects has their own copy of the members that live in the blueprint. They have their own memory that's allocated for those members. Okay? Okay, so let's set link's health to 3. So I'm going to type myLink, and the way that you access members of a class or a structure is the same. Use the dot operator. Okay? But this highlights the one difference between structures and classes, and that is the access modifiers that you have. So I can't set the health here. I'm not allowed to. And I'm going to show you why. There's an error there. Because the one difference between classes and structures is that by default, nothing outside of that class is allowed to access the data or functions in that class. When I say access, I literally mean I can't look at, modify, touch, investigate, do anything with that variable health at all. Right now, that variable health is completely worthless. I can't do anything with it. It might as well not even exist because I can't set it. However, look, this is the error that you'll get, by the way, when you build. And you have a, can you guys see this? Member link health declared at line 8 is inaccessible, which means you can't access it. You can't get it. The difference between classes and structures, and this is literally the only difference. Everything you can do with classes, which we're about to learn for this entire class, you can do with structures. It's literally just a difference in the name, okay? And one other piece, which is that structures, by default, you can access everything inside of them. So now I don't have a build error. If I recompile, we'll be happy. So this gets into why would you use structures over classes, for one thing? Mostly it's kind of like what I want to call it, whatever's easier to use at the time. It depends on the kind of intent that you have. Usually we use structures internally on Overwatch for things that are small, have just variables and no function members. That's kind of, there's no real hard rule of thumb. It really doesn't matter. If I want all the members to be accessible by default, I make it a structure. If I don't want them all to be accessible by default, then I make that a class. It's kind of like whatever you have the most of, I guess. In this case, link is going to be a class. So, I need to talk a little bit about data access. One, why does it exist? Why does C++ even have the concept of I can't get this variable? What's the point? Like, a lot of other languages don't have this concept, like private versus public or hiding variables, because I can see it. Like, I can change that thing to a structure as a programmer, and I can modify it. This is going back to the concept of guidelines, right? These are rules of thumb, best practices that you can follow to make your game more robust, to make it less buggy, to make it be able to have features added easier. This is a concept that is completely optional for you to use. You don't have to use it. However, if you use it well, it'll help you make a more stable game or a more stable program or whatever you're doing. And that's called hiding. So the reason why this thing exists is mostly, in my experience that I've been doing this over the last 12 years now, the biggest reason I see that this happens is you want to describe intent to other people or even to yourself that are using your class. You want to make it clear what should and shouldn't be used by people that access this class. It's kind of a weird idea. It's kind of hard to explain. But it's kind of like if you take a car, right, or your iPhone. Let's use your iPhone, for instance, right? Or your Android phone, right? You can interface with your phone in lots of different ways through the screen or through the buttons that are available to you. But a lot of phones won't let you change out the battery. They hide that concept from you. They hide the concept of the antenna. Apple does things like hide the concept of a headphone jack, which is silly. Even laptops are like this too, like hiding the internals of the CPU or like the GPU. It's not that you own that thing. If you really wanted to, you could open that thing up and you could change out the battery, or you could like replace the parts if you were so inclined. Yeah, void your warranty. But those guys that make those devices are trying to make sure that you're interacting with the device in a way that they've tested and they understand the extent of how those interactions will behave. They know pretty well how people are going to interact with a touchscreen, but they haven't really tested or accounted for you messing around with the battery on your phone. So they hide those concepts away from you. So when they're presenting you with a phone, it's like, oh, nice. I don't have to worry about any of that stuff. I literally just worry about what's in front of me. That's the exact same reason why access modifiers exist in C++. When you're giving someone or yourself an object, you want to make it clear what you should or shouldn't be messing with. Because sometimes the things that you're messing with have side effects that you're not accounting for. For instance, health is a perfect example. Let's just say that I let anyone who has an object for a link modify the health however they want to. They just set it to like -1 billion or 360,000 or whatever value that they want to, right? So what problems can come up if you just let anyone set the health of link? Let's talk about that a little bit, because this is important to why access modifiers exist. So if I set the health to -100, what would you expect to happen for a link in the game? Let's say someone just sets his health to -100. He would die, right? And he would respawn. Well, here's the thing. Setting his health to -100 doesn't necessarily cause him to die. It just means he now has -100 health. Oftentimes, the behavior for killing Link is part of the function for causing him to take damage. You tell Link to take 1,000 damage, right? If he had 1,000 health, then now he'll die. A lot of times in games, that behavior is tied to that function. You need to call other lines of code. For instance, let's just say I'm going to set his health to -1,000. Now Link is running around with -1,000 health. Okay? He literally has -1,000 health. He hasn't died yet because someone somewhere just set his health to -1,000. The code that's responsible for actually killing him never ran. Some intern somewhere just said, oh, I just want to set his health to -1,000. So let's try that. And I'm going to show you the repercussions of what that means and why it's important that we have these things. So the way you specify access to your members of your class is via 3 different modifier keywords. And those modifier keywords are private, public, and protected. And the way they work is you type in the modifier, and anything below that modifier is considered a part of that group. So for instance, here, public, I type public : and everything below that colon, below that access modifier, is now considered to be public, which means that it's accessible from anywhere that you see that class. Means that anyone can access those members. I can also declare something as private, which means that the only things that can access this member are things within that class itself. And I'm going to show you what that means when we deal with a function, because usually that means you have a function that's private too. And then you have protected members, which means that anything that derives off link can access those too. We're going to get into more about protected. Protected is kind of worthless right now because we haven't learned about inheritance yet. But keep in mind that there is a third one for protected. Protected behaves a lot like private, except inherited classes can also modify that variable. Okay, let's talk about private here. Oops. Private is the default access modifier for a class, which means that if you don't have any access modifiers declared, every member will be private by default. So this is redundant. I don't need to put private here. Everything is automatically private, like so. This is equivalent to having a private access modifier. You can add multiple. You can do private, public, as much as you want. There is no limit to this. It just means that everything after that access modifier is any members declared after that access modifier belong to that type. So anything here on line 11 or anything else I add between these, A, B, and C are all public. D, E, and F are private. Okay? It just goes down until it hits the next access modifier. Okay? Let me show you why you would use these. Let me get rid of all these. I'm going to declare a public section above my private section with a function called take damage. So this is an example of me declaring a function member. This is me taking it from my Notepad document. I have my take damage here function. I can tell link to take damage. And I have a private section for health. What does this look like now when I use this? If I do a dot on my link object, I am presented with a drop-down box with everything that is considered to be public for link. So I have a function that's public for link. I can tell link to take 1,000 damage. I am calling that function on the link object, which means that this function is mapped to this function up here in the public section. What would happen if I made this guy private as well?
It would get angry at you.
it would say there's a build error because I don't have access to that thing. So why does this distinction even exist? Okay, so I'm going to go into a little bit more detail about why you would do this. So our take damage function is going to take health and subtract it equal to the amount. Okay. And then if the health is less than 0, we're going to okay. So here's our statement. Every time this function gets called, we're going to print out to the screen that he took damage. And if his health is less than 0, we're going to print out that Link died. Okay. In this case here, instead of just printing out that Link died, in the actual game, what we'd probably do is have him play an animation. We'd show a screen. We'd do something to actually indicate that you can't move him around anymore. Oftentimes, you have to like prevent input from happening. But that's all in this function, right? We just tell Link to take damage, and we figure it out. We're going to call that function take damage. So let's see what happens. Okay, so Link took 1,000 damage, and then Link died. Cool. I called a function, and it figured out that he died. Let's set his health to 3 for now. And I'll show you guys how to set his health with a function. So Link took 1,000 damage, he died. What happens if I just ignore this function? What happens if I just make this guy public as well? Or in this case, I can just remove the public modifier, since I already have a public modifier here that applies to health. Let's say I don't do this at all. Let's just say I say mylink.health equal to negative 1,000. What actually will happen in this case? Nothing prints out, right? That behavior for having Link take damage and then die if he's less than or equal to 0 health never happened, because I'm literally just poking in and modifying the health directly. It'd be kind of like if in your car, every time you wanted to make the car accelerate, you literally had to like be hanging on the hood and be like pulling on the throttle cable, like every time, like just to make the car move without going through the accelerator to do that. Or like maybe even a more extreme example would be literally in order to make the car move, you have like a crank connected to your axle and you're like turning it directly. You're bypassing all the safety protocols in the engine and you're just like making the car go. This right here is me drilling in to modify the health directly. This can lead to some unsafe behavior. Particularly, it can lead to problems where someone has written code to handle what happens when you take damage, and now you're not calling that code whenever he takes damage. Which means that you can end up with situations where Link actually doesn't die, even though you set his health to negative 1,000. Okay. So here's the rule for this class. And this is a rule we're going to follow unless we have a good reason not to, until we get comfortable with using classes, which is that I want all of your data members to always be declared as private. And I want you to follow that rule for every class that you write. So any data members that you have inside your class should be marked as private. And anything else that you have can either be marked as public or private. So functions can also be private if you want to. So private here, this is interesting. I didn't really talk about like who can actually access this when this thing is declared as private. I can't access it out here. This is an error, right? I can't modify the health here. But here inside this function, I have a health. So I want you guys to think of a function that lives in a class, and when you call that function, that you're kind of like changing rooms, like you're changing where execution occurs. The scope of the execution of this take damage function is within the object itself, is within the link object, which means that I have a variable I'm accessing called health. Where is that variable declared that I'm using inside this function? It's right here, because it belongs to that class. You know what else belongs to this class, link? This function belongs to that class. Because both the function and the variable belong to the same class, that means that this function can access the private member. This variable is private to the class, which means only members of the same class can access that variable. Which means this right here is the only place that I can actually access health. This function is the only place that I can modify health. No one else can see health. Which means that if you want to modify health in our game using our class, you have to go through that function when you're writing your code. You have to call that function. So if I want to set Link's health to 3, what do I have to do if I want to set his health to 3 from down here? Does anyone have any idea how I modify his health? What do I have to write to get his health to be set to 3?
Have a setter function?
That's a good point. That is correct. Because I can only modify the health via public functions, I have to create a new public function that sets his health. But here's the nice part here. Because I have a function, this seems a little bit redundant because literally all I'm doing is health. However, it's not quite redundant because you can add some conditions. If his health is less than 0, set his health equal to 0. So you can't set his health negative. Else if health is greater than 10, this right here is the best example I can think of as to why you even want to have access hiding, access modification at all. Because you can call that function with whatever number you want to, but the only numbers we care about are numbers between 0 and 10. So even if you pass in 1 billion, your health will be capped to be 10. So if I want to set Link's health, I'll set his health to 3, and then I'll set Shadow Link's health. I'm not modifying health directly. I'm modifying it via these setter functions, set health. And those functions will guarantee that my health will never be lower than 0 or higher than 10. You can see Shadow Link's health is 10 here, even though I've told it to set it to 5,000 or 5,123,000. And that is why you use access modifiers. And that is why I want all of your members to be private. Oftentimes, your functions that are used to modify the data members are going to be very simple. They're going to be setting it or getting it. But sometimes you'll have more involved things. We can write another function now to actually get the health for Link, which is the only way we can actually know how much health he has. And this function here is literally just going to return health. It's just going to return the health that lives inside of Link. And now we can print out So here now on the screen, I'm going to print out both of their healths. Not a really big surprise there. This code is not the most complex. It's actually rather simple. But what I want you to really focus on is the concept of hiding data and access modifiers for your class. This is used for every class. This is such a common thing that every class has either some public section or some protected section or a private section. Okay? All right. Any questions on that? Okay. As I mentioned before, by default, classes are all public. All their members are private by default. Structures are declared public by default. That's the only difference between the two. And you can use that to your advantage, because anything that is declared as private, you can just assume something like this, for instance. What is private in here in this class? It's the width and the height, right? Those variables. And in the public are the member functions for set values and area. It has a this part right here where it says rect, semicolon. It's this equivalent to you declaring a variable called rect in your class.
They got wrecked.
Yes. Okay.
Can you also call that too?
That's it.
On the
This right here. This is the same as me going in here. I can do that right here. Like that. This right here is the same as me on the next line doing link my link. Those are exactly the same. Okay? Putting a variable here, it just saves you literally typing that word. That's pretty much all it does. It just saves you from typing that. It's not really useful because it declares it in the global scope. You don't really want that most times. You want this thing down here. And you can't do that with declaring object name here. But I could declare as many as I want to. Now I have, what, 9 links? Each one A, B, C, D, E, F, G, H, I, J. It's a shorthand way of doing it. Honestly, like, I don't know if that's better than doing this. I personally think it's not. But we don't actually like use the built-in object name creation. We don't use this at all, almost ever. So I wouldn't use it either. Okay. Just keep in mind the difference between the class name and the object name. The class name is rectangle. The object name here is rect, R-E-C-T. Same relationship that an integer and the object A that represents integer is. Where int is equal to the type name and the class, and A is the variable name which represents the object. As I mentioned before, if you want to get at the members, whether it's a data member or not, whether it's a function member or a data member, you're going to use the dot operator. The dot operator lets you access any public members of that class. Okay. So in this case, you have an object called rect, R-E-C-T. You can access 2 public members of that class. You can access set values, and you can access the area function. Both of those are functions. Those are the only members I can access because those are the only public members. I can't access width and height because they're private. Here's an example of the full implementation. You can actually see the output of what area prints out. I'll go over this in a little bit more detail, because it's introducing another operator which we haven't seen much yet, except when using std for namespaces. So let's take this, and I'm going to have a lab for you guys. I'm going to have you guys take a break and then go to a lab. So if you take a look at our link class here, the way I've defined my functions, like let's say get health, is I've literally put the function declaration and implementation, which is the stuff inside the color braces, in the same place. But you don't have to do that, and oftentimes we don't do that. So we're going to talk also today about using multiple files in your solution, because there are benefits to having your class split up across multiple files. So if I wanted to take this, get help, I can just create a prototype for it instead. I don't have to put the implementation there. I can take this and I can literally put it down here, outside of the class declaration. I'm going to put it on line 39. But the way I do that is I specify, hey, I'm implementing the function called getHealth that belongs to the link class. And I do that by specifying the type, the name of the class, and then putting a set of double colons in here to represent the namespace it belongs to. So that's what you see here in rectangle. There's a prototype for set values at the top inside the class declaration here. And then the implementation is on line 12. And the implementation is specified by having the class name for rectangle, : set values. All right.